Hi, hello everybody. We are here with another DCG development update today with the platform team, with the core and the mobile team. We are planning this session for 1 hour. If you will have any questions that you would like us to address in the Q&A session at the end, please use a Q or a question prefix to your questions so that we will know that is uh, directed to that session. All right, without further ado, let's jump in. Let me share my screen as well. And I give it to Sam. And let's start with the platform team.
Yep, thank you very much. So we have a lot to share this this review. We have some very good news and also some kind of sad news. Igor left DCG. It was his last day on last Friday. And we wish him all the best. He's not going to participate today as he's already left. So me, Igor, Ivan, and Lukasz were working on platform. Lukasz was also working on TenderDash. Ivan and Paul were working on strategy tests and terminal user interface. And Evgeny and Odysseus were working in GroveDB. For Evgeny's work, we just in GroveDB, we decided not to present it today, and instead he will Evgeny and Lukasz are currently on vacation, so they will not be around. Lukasz made slides around his work, and Ivan's going to present them. Evgeny, it's a lot more, not inside GroveDB needed. It's best explained by him, so we're just going to do it next time. Okay. So I have a little surprise for everybody. A lot of people probably already know this, as surprises can't be held back in an open source environment. But we're going to start with a little talk about what platform documents are. Ooh, there should be a question mark there. Sorry. And we're going to have a little discussion on what we've built in the last 2 weeks. So what are platform documents? So when we have a data contract, in a data contract, it has specific document types, and these define what a document could be. You can think of documents as a queryable instance of a document type. They have an identifier, and that's unique to within all documents of a document type in a contract. The documents can represent any data that anyone wishes to store. That means like it can be an individual, a reference to an individual. We're not going to take an individual and cram them into platform. A physical resource, a digital resource, and documents can be searched. This is kind of what we built, and you can prove all. You can do secondary index searches on documents. You can basically everything that platform brings, and any query can be proved, and that's what we've been building for the last 4 years. Now, this is the new part. Let's go on to the next slide. What are NFTs? This is something that has been coming up quite a lot when people have asked, are documents NFTs? So let's first talk about like what is an NFT? A non-fungible token, and this is from Ethereum's website, right? So I'm not making anything up. This is what an NFT is. A lot of people in the crypto space don't understand what an NFT is because they see NFTs and they see like a picture and they think an NFT is a picture. No, that's not true. It's used to identify something or someone in a unique way. So what an NFT has a int UN 256 variable, that's 32 bytes. You divide by 8, just for people interested. So 32 bytes, called a token ID, and um, the token ID must be globally unique. The dApps themselves can have a converter that takes the token ID as an input and produces an output. Like the output can be information about the token, the NFT. And NFTs can be transferred and often sold. So when we look here, like, okay, our documents have a unique ID that is 32 bytes. NFTs have a unique ID that is 32 bytes. Documents represent data. NFTs represent data. Uh, then we get to the obvious question. Let's go to the next slide. Next slide. Our platform documents NFTs. So the goal of an NFT is to represent ownership of a non-fungible amount of data. Documents do this. They can also be indexed, search, and have structured data right there. So there is no need for an indirection for non-bulky data. So our documents are NFTs, and it's come up quite a lot when I said, we have NFTs. People called me out and said, wait, no, we don't, because they can't be transferred and sold. So what do we do? Next slide.
I think we have a delay.
Oh, okay. The
Okay.
solution is to allow documents to be sold and transferred. And hallelujah, it's now in the version that is out there since yesterday. Documents can now be transferred. Documents can now be sold. What's left to be NFTs? According to the spec on NFTs, nothing. They can be instant, and our NFTs actually have some benefits over I would say the classical idea of an NFT. So the thing in Ethereum is that there's an interface and you have to implement the interface to have an NFT because it's code based. In our situation, it's document based, so literally you only have to put in a few truths, like booleans, to say is transferable, true or false, is sellable. No, I think it's trade mode into purchasable or something like that. Um, so it's quite easy to for our developers using Dash platform to get started with. But there are some caveats. Let's go on. Restrictions on NFTs. So like if I had a document, let's say I had a contract that had that represented, let's say, ownership of land, right? Ownership of land in a country. And like it says that I own this plot of land, right? If anybody can make an NFT saying that they own the plot of land, well, there's no value in the NFT, right? So one new feature that we also needed was restriction on document creation or an NFT creation. So if anybody can create the NFT, then there's no value to it. Basically, you need a solution to create it and then a solution to distribute it, right? In the case of land ownership, right, you would have the one time, I don't know, the government, I guess, for the country who surveys the land, I guess it's government, say that that who owns what land. Not actually sure if that works the same in all countries, but yes. We allow the restriction on NFT creation, which is necessary. In the first version, the restriction is the contract owner. So basically, somebody makes a contract and then they can restrict it. So only the owner of the contract can make a document within that contract. Documents can now also, so before we had one flag that said if documents can be mutable. And that mutable flag governed if they could be altered and if they could be deleted. But there are specific cases where you'd want to create tokens, like an NFT token, that you would delete, but that you would not actually modify. Obviously, if you can modify an NFT, there's not much value to it anymore because anybody could modify something into something else, right? So generally, NFTs are non-modifiable. So non-modifiable, but sometimes you want to delete and you want proof of deletion, you know? Um, Maybe like you have a specific ticket that can only be used once, right? And because it can only be used once after usage, um, you can delete it to recuperate the space of owning the NFT because it could never be used again. So might as well get that space back for you. Um, and when you delete something that you own on the blockchain, you get money back, right? Because you're removing expensive storage from the state. So it's kind of like a cleanup mechanism that rewards users. Okay, so let's go on. Oh, yes. So this is all great and dandy that we have this functionality, but it's so much better when we see the functionality in usage. And Paul has made a very nice demo showing this in the text user interface.
Yeah. Okay. I'll show it now then.
Paul, we switched two slides, by the way, if you're confused.
Did
What?
we?
Wait, what?
No, I switched two slides, so the demo would come first.
Oh, okay. Should I do the demo now? Sorry.
Yeah.
Okay. Yeah. So I'll share my screen. All right. So I'm in the platform terminal user interface. This is the home screen. So let me just change the loaded identity. Okay, sorry. Don't worry about that. So from the home screen, I'm going to go to contracts by pressing C. And these are the known contracts, like basically contracts that the terminal user interface has interacted with already. Um, and I populated this one. You're seeing right now the IDs of each contract. In the future, like soon, we're gonna actually register. Well, we're gonna add functionality so that you can register contracts with DPNS, and then if they have like a DPNS name, you'll be able to actually see the name here. So it'll look better than just some random numbers and letters. But I populated this contract 62 with some documents already, um, which are actually non-fungible. So they're NFTs. So I'm gonna hit enter to select this contract, um, and
And
enter again.
can I just quickly, yeah, go on in. So
Yep.
the contract that we're using here is a contract that represents a trading card game, right? We didn't make like a very advanced trading card game, but if anybody's ever played, things like Magic the Gathering or uh, I don't know, most card
Pokemon.
games, yeah,
Yu-Gi-Oh.
Pokemon, Yu-Gi-Oh, or one of those games in their childhood. generally the monsters had an attack, a defense, an image, and various other features, right? And we just added these in very quickly to give like a um, a a demo of what is possible on platform. So like, you can store all this information in here. Like here we have an attack value, a defense value. If we go down, we have the indexes that are currently that we have active. Like you can search by owner ID, you can search by attack, you can search by defense. Um, yeah.
Yeah, and there's fields for image URL, image hash too.
Yeah, exactly.
So
So
yeah,
let's go.
yeah. So I'm gonna press F to query. It will basically query documents from this contract document type, and you can put in a SQL query. I'm just gonna select all the cards, so it's gonna display all of the documents that are registered to this contract of this document type. Um, so yeah, here on the left we have the each document ID, and going down it's sorted alphanumerically, and you can see the data that each document holds. So owner ID, price, attack, defense, these are just random generated numbers. So yeah.
Yeah, we should probably make them
Name-
positive numbers in the future, but it's
Right.
fine. It's
So yeah, you can scroll through each document and see the data. And basically, what I did yesterday was, if you see here, there's an option to purchase this document. So basically, if you're not the owner and the document has a price listed, then you can purchase it. Yeah. So these are purchasable. The first three. The fourth one has no price, so it's not purchasable. This one is I am the owner of it, so I can set the price or I can transfer it. Let's first I'll purchase. So I'll just
yeah.
purchase the first one.
I just want
The
to add
price,
for
yeah,
people that are wondering, transferring is as if you are giving it away, right? Or maybe somebody gave you $10 in actual cash, like if you're in the US and you're using dollars, and then you just transfer it to them, right? Uh, so we also, I mean, they're two actual separate features, transferring and selling, but they kind of get lumped together because there's the idea of giving it to somebody else.
yeah. And if you transfer, you pay the fee, right? But if someone purchases, then they pay the fee.
Yeah, that's correct. Also,
Yeah.
these prices are in credits, right? So it's 10 to the power of minus 11 to get to Dash. Right now, the interface isn't ideal. This is not something that a user of platform is ever actually going to see, right? There's much better. I mean, the developers will basically create a nice interface for whatever contracts that they have in mobile apps or on web apps or other things like that. This is just an easy interface, like actually a quick and dirty interface that we've whipped up. So uh, yeah, this is in credits.
Mm. Yeah, so this price is actually point 0.1 dash. So you can see my balance at the bottom right. I have enough to purchase it. So I'm just going to press P to purchase, yes to confirm.
Oh
And of
no.
course, there was a connection error.
Oh, this is just a
Prob
connection error.
Yeah, I can probably just try again. That was the first error I've had of like playing around with this all day. That's pretty funny. Yeah, I don't know what that was.
Hmm.
Okay,
I've
so
never actually seen
successful.
that either. Maybe I don't know. It's the way things are, you know. You have a demo, the demo gods are angry at you. So
Yeah,
yeah, so yeah, there we go. We just showed that somebody could purchase something, right? And the price is
right.
now gone from the document that you just purchased, right?
It should be, but I just did this yesterday and it's not perfect yet. So I need to go back. I'll just go back now and requery. And yeah, now the price is gone and the owner ID has changed to my current
Yeah,
owner ID.
yeah, because when you buy something from somebody else, let's say that it's 0.2 dash, as soon as you buy it, it's no longer for sale, right? If you want to make it for sale again, then you have to say, "Oh, I allow it to be for sale again," but you don't want to buy something and then somebody else take it away from you. It's now your property. So,
Yeah,
in this trade mode, um, basically you can put the price, and then anybody can, if they have the money, you get the money, they get the item. It's pretty simple.
yeah.
Nice.
Uh,
So I
I think we didn't do the set price functionality.
yeah, okay, I can do that now. So now that I'm the owner, I can set the price for this one. So press S and amount in dash I'll set to just 0.15. And just waiting for this. Yep. Okay, success. Now let me requery it. And there's the price.
Yep. And now somebody else can buy it from you. And you can see down here, people, that the revision has now changed as well. If you were if you wanted to try to modify the attack or the defense, you would not be able to, because the card is an NFT that's non-modifiable. I'm not sure if in the contract you said it to be deletable, but can you also try the creation
Creation. Yeah, sure.
to show people
Uh,
that you could?
yeah, I can. I'm just noticing right now though, the name is empty, which is like the other ones aren't. And I'm assuming that's a unique index, right? Name. Let me see. Because if that's the case, it would be like super rare. If that was, oh no, it's not.
What do you mean?
Um, because the name is blank. If it was a unique index, that would make it super rare, right?
Um, well, I don't know. I think that we're just doing a random thing generator, right? Up to a certain amount of characters. And in this case,
Yeah,
this one just has characters.
yeah.
So,
But there can only be one blank name.
oh,
That,
that's true. But I don't
yeah,
think they're unique in this system,
no,
in the
no, it's
contract that we made. But yeah, you could definitely.
not. So I think the current identity I have is not the owner, but I'll try. From here, I can press B to broadcast a random document. I'll do try three. Okay, yeah, I got an error because this contract uh, only allows the owner to create documents.
Yeah.
So, yeah, let me change to the owner.
Right now, he's switching to the identity that created the contract.
Yes, thank you. And now broadcast 3. And there's an error. Potentially, I don't know.
Maybe
Yeah.
query them. They're there?
No, there were no new ones created.
Try just creating one. Well, I feel like it's more of a, I mean, the tests definitely have this working, so it's more of a, what's
What is
going,
this?
is saying like transport error?
Yeah, transport error. Some nodes are getting banned.
I think that this has something to do with you using it too often. I don't know.
I don't know.
Interesting. Um, Ivan, did you do anything with making queries bannable
Not on
recently?
testnet.
Not on testnet? Okay, well, we'll investigate why that's the case. But we had tested it just earlier and it was working, so I'm not really sure what's going on here.
Thank you very
The
much for
Moore,
sharing.
the Moore law.
Oh, yeah.
There we go. No, wait.
No, it's an error.
Now it's
Jason's
the
error.
Yeah, we have the
oh,
error, at least.
so the image URL is not valid.
Yeah, I think the random generator wrong here.
Yeah. Okay. Well, there you go. You have to create an image URL that's valid. So that's the problem. So it's not a problem with platform. It's just a problem with the creator. Okay. Well, thank you very much.
Uh-huh.
Thank you, Paul.
Let's you want to continue with strategy tests and the other work you did this sprint?
Sure.
Yeah, let me share the
Sure.
screen. What that?
Yeah, so since last review, I worked mostly on strategy tests. I just did the NFT stuff the past 2 days. But yeah, I worked like basically ironing out some bugs to make the load tests more compatible with strategy tests, and they're working really well now. Well enough for me to actually run strategy tests and start collecting data, which is what I spent actually a lot of time doing, kind of like optimizing some, like creating some default strategy tests and optimizing them so that we can reuse them to basically see like if we create a new release on testnet, we can see how the new one compares to the old one. And these strategy tests are actually uh, uploaded to a new repository in the DashPay GitHub. It's called Platform Strategy Tests, and we basically you can export strategies to this repository, and that's where they all live. And then you can import them into the TUI and run them yourself if you'd like. And the repository also has all the stats for each one, and they're versioned based on like which version of testnet they were ran against. Yeah. And besides that, I also created a usage guide for how to use strategy tests, basically like a quick start guide, and then also goes into a little bit more details of what strategy tests are and common errors and stuff like that. and it's published on the official blog, dash.org/blog. So yeah, if anybody goes through that guide and runs into any issues or has any questions, you can ping me, please, and maybe I need to add something to it or whatever. So yeah, that's it.
Thank you very much, Paul.
Thank you.
Thank you. Shall we move forward? Sam?
Oh, sorry, I had muted myself, but this is not mine. This is
Then
Ivan.
Ivan.
Yeah, that's me. Thank you. Hello, everyone. This sprint, we also worked on the HTTP traffic observability and security. Let me explain what does it mean. So if you remember, we are a couple months ago, we were super busy with stress testing when we broadcasting transactions and monitor how the blocks are producing, how fast, and tried to limit and to secure the P2P traffic, so the traffic between the Tender Dash nodes, to make sure that anyone cannot like spam and spoof the transactions and pause or even stop the block production on Dash platform. This is basically the second part of the equation. It's we have a P2P interface, right? When Tender Dash communicate with other nodes, and also EVA nodes, they expose HTTP interface as well. So people who building web applications in browser or mobile devices or server side, they can query the data that was created with state transitions in platform state. And this part was revisited during the sprint to make sure that we have a clear picture on what's going on there and make sure that this HTTP interface is secure. So I think the best if I will share my screen and first of all explain the architecture of the gateway and how the HTTP traffic goes. Give me a second. Do you see my screen?
Yes.
Excellent. So yeah, I draw a really quick diagram to explain to you guys what all these things means really quick. So we have the clients and it's basically the internet, and each master node, its EVA node exposed the HTTP port as well, not just P2P ports, right? So people can send queries and broadcast state transitions and transactions using DAPI and Drive. So in front of that, we have the HProxy, what we call now gateway, and we use the Envoy proxy server for this. And Envoy is proxying the traffic through to the Drive or DAPI, and actually Drive more services, but I wanted to simplify the picture. Yeah, so I will come back to the slide. So now you kind of understand the how it looks like. We'll come back to this diagram later.
Do you want me to share?
I just
Or are you going to share?
it's not opening for some reason. Yeah, I mean, probably I will do just give me a second. Yeah, just open on my
Have
in
you
the
opened it?
browser. Yeah, I did. Am I still sharing my screen? Balazs?
Yes, I think so.
Okay, cool.
Oh,
So-
no. Now I don't see it. Can you reshare? Yeah, thank you.
Yeah, all good now. So the first of all, we updated the version of Envoy and configuration because we used the pretty old one and there were like tons of vulnerabilities since that found in the Envoy proxy. So we updated to the latest version, and the main goal basically of the work once again is to secure the HTTP stack from possible attacks, and we're talking right now more like about denial of service attacks, and provide better visibility on what's going on there. So like to introduce some instrumentation and provide better observability of the services so we can see how traffic goes and where do we have problems. So I'm not gonna explain all these like technical details here because it will take too much time. But basically, we introduced several layers of limiting. There is a dynamic limits that based on the memory consumption and active connections. And also we have the limiting for incoming HTTP requests by IP address, and we can set up now white and black lists. We have also the control on maximum concurrent requests to specific upstream or even endpoint. I mean the DAPI drive and specific endpoints. So everything is very configurable and flexible. And there are some additional configuration in Envoy to sanitize HTTP requests to prevent attacks, additional configuration of the buffers to reduce the memory consumption for connections, for streams, and stopping the timeouts and the duration and idle timeouts for connections and requests. I should say that in why I'm saying about connections and requests, each connection in HTTP1 with keep alive would like produce multiple requests that contains multiple requests. And if you're talking about HTTP2, then due to multiplexing support in this protocol, with one connection you can send multiple requests. It's called streams in term of HTTP2. So we have additional limitation on this area as well. What be interesting for you as well? Yeah, the nice thing that we enforced the only HTTP2 connection between the Envoy and DAPI or Drive. So it's much more efficient because you don't need to keep hundreds of connections for each client, and all requests just go through the couple of 3 connections between them, which is very efficient from a resource point of view. That's what I observed and was wonder how it's cool. And yeah, of course, regarding the observability, we added so with Dashmate you can configure the logs for Envoy, and you can add any number of access logs and define the format of these logs, like JSON or text. They could go to SDAUTs there or to files, and you can define the template, how this string output will look like. So basically you can set up Envoy for any monitoring system what you use to make sure that all good on your side. Yeah, and we expose the Prometheus metrics from all related components, including Drive, Envoy, and rate limiter. We don't have DAPI in this list because we are going to revisit DAPI endpoints very soon in order to protect core RPC. That's another story. And then we come back to DAPI. So the endpoints will be reworked. So there is no point to touch it now. And we visualized everything in Grafana so we can see what's going on. And to basically to provide the load, the data for testing, we implemented a query load tool that we had one that created the broadcasted state transitions, and this one is basically can make the queries to our network. So let's go back to the diagram, and I will try. Oops, no, that's not diagram. Yeah. And I will explain a little bit how we see the security right now and on which levels we guarantee it. So yeah, there is even node. And your traffic goes probably through some like routers, or you have the special hardware to filter your traffic. We'll come back to it. Then we go to the network, the host network layer, and that's where some low-level network traffic filtering should be done. I will talk about it later as well. And the part what was actually updated during the sprint, the area of our interest right now is the Dashmate. And Dashmate runs all the services in Docker environment. And this is a simplified view. We have much more services, but right now what we're interested is in Envoy, the gateway, and then the upstreams, the Drive and DAPI. These two services that handles the HTTP traffic. So all incoming HTTP requests eventually goes to the Envoy, to the Dashmate, and we have 3 layers of defense on this level. So I already mentioned we have this dynamic rules. So basically we can specify in Dashmate config that if Envoy takes more memory than this limit, then we start to execute the rules. And at some level, and 92%, we stop the keep alive connection. So you need to do 1 connection per request now, and that allow us to more granular control the incoming traffic, and it reduced the memory consumption as well. And so you don't need to keep the connection pool all the time. And we also trying to shrink the memory, so reduce the free memory. And Second level is we are measuring active connections, and if again the connections go closer to the limit defined in Dashmate configuration, we disable keep alive, and at some point we just do not allow to create new connections. So we protect the node from the overloading, so it still can proceed the operate properly and filter the traffic. This is a global limiting. And after that, in the chain, we have the HTTP request limiter. Previously, we had it as well, but it was globally, it was global for all requests incoming. So basically, if I sending, I mean, you can experience this right now on testnet. If you're sending like 150 requests per minute, then other people won't be able to do requests to this node at all. So that's not what we want. And yeah, now it's based on IP address, and it's also configurable right now. If I'm not mistaken, we have like 150 requests per minute, and so, but we're going to adjust this number during the stress testing in the future. And so when we are limited requests by IP, the last defense here is the circuit breakers for each service. What we providing, the drive for DAPI or specific endpoints on the services, they have the limit of concurrent requests, what they can handle. So, for example, why it's important, for example, drive, it's not just handle the queries, right? It's also the processing the blocks. And if you send too many queries to the drive, then the asynchronous runtime, the Tokyo runtime, what we're working there, will be overflown with queries, and that makes slow down or even pause the block production process. So idea that we can see the amount of requests what we can safely process simultaneously, and that won't affect the block production, so we can limit with this number the incoming requests. All these like measures, and the mechanisms, they won't protect your node completely from DOS attacks for sure. It mitigates them, but if we're talking about more complex attacks, and especially distributed attacks, we should also consider some additional filtering rules on the host network layer, so on the host machine, not in the Dashmate. And also we probably need to consider some, if you're talking about something very bad, to consider to use additional like the external protection services or hardware, or the Sentry nodes approach, when you have kind of proxy nodes in front of your node, and but the node itself that does validation and block production won't be affected by incoming traffic. That's usually how currently networks protecting validators in the industry. So we will provide some additional guidance on this topic in the future, and so it will be covered at the point of release. I would like to, might be was a little bit boring, so I would like to show you something interesting. This is a Grafana dashboards what we made to visualize the HTTP traffic. Okay, so we have the special nodes for our DevNets, what we call load test nodes. When we're running the load test tools, so I'm going to run from 3 nodes the broadcasting random queries with like 10 connections and with rate 100 transactions per second. My goal right now is not like to crash the network, but to show the visualization and how traffic goes.
What network are you doing this against? Just curious.
OZA.
Okay.
So now we can see that number of connections increasing and number of requests also increasing. So now we have 7.4 requests per second, and it's growing. So here on the graph, you can see the active requests, like the concurrent requests. But since the number of requests that I'm broadcasting very low, it's like almost 0 because they're processing like very quickly. Yeah, we can see no, the number of errors is not growing. And why I choose the small number? Because we have pretty strict rate limiter rules right now. And here on the graphs, we can see how rate limiter by IP is working right now. So it's like 14 requests within the limit. And also we have 3.2 close to limit and like 21 over the limit. So rejected basically. And we have the visualization also to see how quickly the rate limit service is working, because for each request, we need to go to the service to get the response if this request is okay or not. And this is important metric. So we see that everything within 10 milliseconds, it's fine. This graph showing this is actually the response from this service, only like execution part. And this one including the networking. It's a bit higher. Actually not, it's like the same. Yeah, so we're gonna play with this too to make sure that all works good. And here below we can see the information for each upstream. So this we have an admin upstream, it's for admin interface, DAPI API, DAPI core stream services, DAPI JSON RPC. This the drive queries is the place actually where we querying right now. And for rate limiter, since it's also dedicated service. So here we can see that number of active requests that goes directly to drive, and it's pretty low because it's limited already on the top level. No errors and no timeouts, so it responds pretty quickly. And this is information from the rate limiter specifically for this upstream. So we can see that we have 20 rejected and 8 pass in. So what else? Interesting, more detailed information we can see on these graphs. We definitely want to add additional drive dashboard later. So it's right now we can see it on the performance test. So each row represents the specific drive query endpoint. So we can see this get identity keys, get data contract. And on the chart left, we might see the number of requests per second and also the response codes. I'm broadcasting right now also getting identity with our identifier, which doesn't exist in the state. So we're getting not found as well. You can see the errors and also it's okay. And on the chart on the right, it's a heat map. So we can see the response time. It's in the seconds here. I probably need to change it to milliseconds to make it more readable. But the idea here is so it's histogram put on a timeline, basically. So we can see, for example, this one is the 14 requests was below the 35 milliseconds. And so the darker, the slower, the darker, the less, darker, it's less requests. And in this spot. So we have pretty slow ones here. So yeah, so we can analyze the performance basically of the endpoints right now and see how quickly they work. But it seems like if we see here, it seems the identities the drive basically warmed up. Probably load the RocksDB files into memory, and it started responding very quickly after some time. That's how we can explain this anomaly. Yeah, that's about the rate limiter. Since it's pretty strict, we cannot see anything interesting. So probably we should just go and disable it. So we can broadcast more requests and graphs should be more funny.
Okay, thanks, Ivan. It's already about the hour mark, so we should probably move on.
Yes. Yeah, all good. Yeah. Please, guys, continue. Yeah, I'm finished, I think.
You want to summarize, or are you good?
No.
No
We're good.
summarization.
We're good. We're good.
Can you
Well,
stop screen share?
Yep, I will.
All right.
Yeah, basically just a couple words that this, I would say it's more like a framework right now for and this thing needs more tests. So we have right now the ways to configure all the limits and see what's going on, and the next step should be comprehensive stress testing when we broadcast transactions, when we do the queries, and we see the load on the system, and we can adjust these numbers for the hardware, what we recommend for even nodes. That will be the final goal of the whole stress testing process.
All right. Thank you very much, Ivan.
Yep.
Odi, would you continue with GrooveDB?
Yeah, sure. So almost very good news. The PR providing the state sync implementation is, I would say, very close to be merged. Probably today. We were planning to get merged this for today's presentation, but we had some refactoring to do and some warnings to fix for the linters. Once this is merged, then the next step would be to extend this basic functionality. By basic, I mean now the restoration of the state is happening subtree per subtree. So there is an optimization opportunity here. For example, at the database we are replicating to, if it discovers that now we have more than one subtree that can be fetched, well, those can be made in parallel, independently from each other, instead of doing this sequentially as it is now. So this is one thing, the parallelization of state sync. And then we need to somehow introduce a checkpoint mechanism that allows us to save partially some state that was successfully completed, and being able to resume from that in case of failure. This will be very useful as more dApps will be joining platform, and hence the GroveDB will hold more data. So we need to implement this, because state sync relies a lot on network, so stuff could go wrong, and we really don't want to start again from the scratch. We need to make it faster and being able to resume from valid checkpoints. So this is what I'm going to work on for the upcoming review, and hopefully I will have both ready by the next 2 weeks. Thanks
Wonderful.
for
Thank you very much.
the time.
And thanks for your brevity. All right.
But before we continue, I just want to
Before,
say how
please.
massive the work is, and the fact that it is in review for state sync is a monumental achievement. This has been being worked on for about a year now. Yeah, since last July. So we're now in review for state sync, and it is, I mean, for the GroveDB part of state sync. The integration part, it will take some more time, but it's just wonderful. So I'm currently reviewing that. It's a lot of code to review, so it will probably get merged in within the next few days. But it's great.
Would you? Yeah. Thanks for pointing that out. Would you continue, please?
Yeah, it really doesn't even do justice to how amazing it is, actually. There's so much to talk about on how I mean, I could nerd out for an hour on how state sync is being used and how it like creates chunks and everything, and how it proves these chunks in distributed way. But we don't have time. It's done properly, and it's like non-attackable. Okay, so let's go on to other tasks. Withdrawal failures from core should never cause platform to stop. Okay, so these are some tasks. So the first one I did, this is basically an issue that we ran into on testnet where core doesn't have withdrawals currently enabled. We're going to enable withdrawals momentarily, but currently not enabled. We're just doing, we're going to do that at the last second and test it out. We've enabled withdrawals on other parts of the system, but I mean on other networks. So we have tested withdrawals before. It's just that yeah, we want to do this at one time because we can't really rewind testnet. But if core were to say that the withdrawal has failed, it would cause platform to stop. And we don't want to do that because we don't want a bug in core to halt platform. So we deal with that in a different way. Basically, the way that this works is if there are any withdrawal failures, where there should never ever be withdrawal failures from core, the failure is actually saved to disk. And people might say, oh, but does that mean that a withdrawal could fail? So for a withdrawal to actually happen, it only needs to be transmitted to core on one of the 100 nodes, Evo nodes. So if it fails on every single one of those nodes and platform still says that the balance has been deducted, all 100 nodes will have the withdrawal actually saved to disk in a special folder. So developers can just have access, ask anyone who operates an Evo node, give me the withdrawal, and we can investigate why it failed and probably fix core to like in the next update to re-enable that withdrawal. But hopefully this should never happen. This is just the mechanism in case it ever does. So we want to make sure that people never could ever lose funds. Implementing, okay, so the next 4 were done by Igor, and I'll be covering them. But the second one was actually heavily done by me as well. So me and Igor worked on that. And it's implementing get identities contract keys. So this is very interesting for DashPay. When you have your contact list, you want to get for all your contacts the list of their encryption and decryption keys. But you don't want to get all their identity data because that would be a massive, massive request to the network. Instead, you just want to say, okay, for these 100 identities, or for these, like, I don't know how many contacts a normal person would have, but it's 100 per request at a time. Get me their encryption and decryption key for the DashPay contract. And this actually was an interesting, there were a lot of issues in this, and this is a very hard query to build out. And it's actually why Igor had been struggling with it for, I think, a month and a half. Some of the functionality wasn't completely working in GroveDB, so we had to make a quick fix in GroveDB to deal with a certain type of optional proof. And yeah, so it's all done now. And now you can make that query. So you can actually ask for the specific contract keys, or in this case, it would be like DApp keys for encryption and decryption. It's very useful for DApp developers who add encryption to their contract. So fixing validation of minimum withdrawal amount, yeah, that's very small. Lightweight get status DAPI endpoint, yeah, so it was just a get status DAPI endpoint, see how the system's doing. We also have a get data contract history query that we have in the SDK that was added. The next ones I don't believe are Ivan, are those?
Yeah.
Yeah, the mostly Lukasz worked on them, but I will talk about them
Please.
really quick. Yeah, so our the limit concurrent state transition pre-validation calls. We're talking about check TX. So the pre-validation what state transition passes before it enters the mempool. And this limiting is implemented on TenderDash level. So it has pretty flexible configuration. So now we can specify how many concurrent ABCI calls TenderDash does to the drive ABCI. And using this functionality, thanks to Lukasz, we are now able to limit the incoming check TX calls to drive. Basically, we're solving the same problem such as with queries when we have too many broadcasted transactions. They should not interfere the block production process. So we want to limit the number of check TX what we're handling simultaneously. The second one, it was the pretty bad bug what led to the chain halt on specific nodes recently. So basically the tender dash nodes didn't get the acknowledgement when vote was actually accepted. And this problem heavily related to the same problem with spoofing these transactions, the network, and then incoming broadcast transaction P2P messages, they fill the socket, and votes might be just lost somewhere there. And node which sent this vote, it's previously just by default decided that it's broadcasted and received, but might be not. And Lukasz introduced the acknowledgement, so on a gossip level, so to make sure that the vote was actually accepted by other node. This work in progress right now. He also added a quick check for our build process to make sure that dependency what we're using to build protobufs is on the particular version what we require. And the last one, Lukasz added change stall information per master node to the public testnet dashboard. So you can see on which master node at which point in time paused the block production or chain halted.
All right.
Thank you.
Thank you very much. Shall we continue? Oh, masternode voting.
Yes.
Do you
So
want to
people
talk
might,
about it?
yeah, sure. So people might ask, how is masternode voting going along? It's actually going along very well. The reason why we don't have masternode voting done today is twofold. The first is we can blame myself actually, but there was a lot of extra work in terms of finishing the work that so as I said earlier, Igor left last week, right? And all the tasks that he had, we needed to merge them in and not just have them like dangling. So I would, while I had started on masternode voting and I was really hopeful that we could finish by the sprint review, just other things came about and yeah, but we'll have it next sprint review. Where are we in there? So we have the state transitions done. We have the queries done. We have the transform into drive operations done. We have the contested resource index done. We have the votes done. What we don't have done is the drive. There are a few drive operations that still need to be coded out. And we also need the documentation finished. We also need the cleanup. So we have work on what we have some of the cleanup done. We have the part on the if you remove a master node that has already voted, its vote actually gets removed. That's done. What we don't have is the oh, I'm not sure if we have that. I think we have that. Sorry, what I just mentioned. We don't have the part where at the end of the voting cycle. So we have the voting cycle that happens, but at the end of the voting cycle, we're supposed to execute the like who won the vote and execute that they won the vote and now they are well, it depends on what they're voting for, right? But in this specific case of contested indexes, that they actually won the contested index. And that has not been done. And that's actually quite heavy. When I said that I was going to have it by the sprint review, once I realized that I might have been like, there might have been a little bit optimistic. Like if I was only developing or only coding, yes, but there's just a lot of other stuff that I'm also doing. So yeah, it will be done by next sprint review.
Thank you very much. Let's move on to the core team. Pasta?
Yeah, thank you very much. So, I feel kind of bad because there's not really a lot of stuff to normally mention. One of the most interesting things in the last couple of weeks is we have a PR open right now, which will migrate us over fully to C++20. That is a very nice thing. Obviously, that was released around 2020, but it generally takes a good number of years for the ecosystem to get fully developed and get everything kind of figured out. I think Bitcoin moved over to C++20 within the last 6 months or so as well. So it's about time for us to move over as well. That's going to introduce a lot of good kind of modern programming stuff that we'll be able to utilize and just have better practices. And yeah, we are as developers excited about that, but probably not super duper interesting. BIP 324 progress is going well. Kitty Whiskers is continuing to work on that primarily. There's just a lot of backports and a lot of networking code that gets changed and refactored. So I'm still relatively confident that we should be able to get that done for V21, but it is still solidly in progress. Bunch of backports. I think we can move on to the next slide here. Okay, yeah, that's fine. So here's the updated kind of percentages of what's going on. Looks like I did not actually update the slide of people on 20.1.x, but it looks like it's actually pretty close to the same, right around that 40% mark. Yeah, we can move on to the next slide here. So here's the list of PRs merged in the last 2 weeks. A lot of backports. Quite a few of those. There's some networking backports in there related to, which is related to BIP 324 and V2 P2P protocol. That's the main stuff. And C++20 is moving along. We haven't been able to merge that in yet, but I think I need to look at CI, but I think my PR to get that finally merged in might be happy now. So yeah, that's kind of where we're at. Yeah, I think we can move on to mobile here.
Thank you very much.
Yeah. Thanks, Pasta. So yeah, on mobile, still broken record. Work on the Rust libraries continues. Did get past a good milestone to be able to fetch identities, so that was a good milestone there. There's a UI component that they were implementing to better support our design systems. So that's an improvement that was made on Dash Wallet. And then we finished the order preview screen for Maya and started into the submit transactions and error handling. That started a bit early on this current sprint that we're on. Can move on to the next slide. A lot of stories got done on the Rust side here too as well. This is the macro side of things. And we had to satisfy some new Apple requirements for some of the APIs that we're using, fixed a crash, and there was some confusion on the syncing status that we got some feedback on that actually didn't have anything to do with the chain syncing. It was actually at one point the rate service went down and it made it look like we couldn't sync to the chain, but in fact it was just that we couldn't get the rates. So we've clarified that to remove the rate syncing status essentially from the home screen. And then on CoinJoin, we better defined the whole backlog for that work, and continued taken care of some of the functions for that feature. We are currently still stuck in the Apple review store. Had a couple phone calls, quite a lot of back and forth with them on what they need for our Coinbase integration. Ultimately, it came to an appeal that I've submitted, so we're still waiting on that. In parallel, we're aside from just trying to get past that particular issue, they're not accepting us to just hide it from the store anymore. So that's the argument at this point, is that it's hidden in the store. It shouldn't be a problem, but they're pushing back a bit on that. We're also on that front working with an S21 approver. This is a partner in the UK that Coinbase works with to get, that's how they got their approval for this. And we're hoping that we'll be able to work with them in some capacity, depending on what the cost would be, to also be a potential way to get past this issue with the UK regulations. That's it on mobile.
All right, thank you very much. So shall we move forward with the questions? I see two questions here. One, Sam, would you mind giving us just a brief on what are the pros and cons for DPNS to go with NFTs, and if they should be NFTs or not?
Yeah, so the pro is you can sell and buy usernames, right?
Mhm.
Which is a very nice pro. Like, let's imagine that I have the domain, like, I don't know,
I think that's obvious.
EiffelTower.com. Nobody cares about that one. So let's imagine that somebody else wanted it. You could sell it to them, right? I mean, it's kind of obvious why that's a cool feature. The con is that when we send payments in DashPay, we have your name. Well, the contacts, like your contacts, are actually the identities that you're in contact with, but you search for them by their name, by their DPNS document, for their name. So if you are searching for somebody and they have just sold their name, you might then make a contact request to the wrong person. It probably is not an issue because generally people don't sell their usernames very often. But yeah, I mean, that could be a problem. You don't want to send to the wrong person. But once again, right, your current contacts that you have in your address book are the ones that you have already. I mean, they would not change if somebody sold their username, right? However, it's more of the social attack aspect of somebody that you think is somebody else.
We might want to store the initial username when you establish the contract, and in interface you can send that previous name was this one and new one is this one, something like this.
So I wouldn't go into the implementation details right now and how we would solve a potential problem. Let's get back to it later. All right, Sam, would you take us home? Last question. What does master voting do?
Yeah, so masternode voting.
And your camera is off, by the way.
Oh, much better. I hate my camera. So what does masternode voting do? So masternode voting gives the ability to resolve disputes when two people want the same unique resource on platform. what does that mean? Let's imagine that there is something that two people want. In this case, a username, but it can be anything that has value that is open for people, right? Now, there are many resolutions to this problem. Two people want something, there could be a competition to who gets it. In this iteration, what we're doing as the first resolver of two people wanting something is a masternode vote. So if two people want something, and in this case, we're going to apply this to usernames, if the usernames are match a certain format, meaning like they don't have a number in them or something like that, then they will go to a vote, and the people can say, okay, I want the username Quantum Explorer, right? Which is the username that I've been going by for quite some time. Once I say that I want that, it will go to a 2-week period where various people can either vote that I get it or not. And somebody else can also register to try to get that username. And if somebody else registers to try to get the same username, well, then whoever has the most votes after a certain amount of time gets the username. Now, we've also provided a way to vote on this inside the mobile apps, and also we'll have it in the text user interface.
All right, thank you very much. If nothing else, then I wish everybody a great rest of the day and see you in 2 weeks. Thanks for being here. Thanks for the comments. See you in 2 weeks. Cheers.